for example, we have this graph right here. We used to be able to find what the area was under. What we want to look at now is volume. As in, if, for example, if we rotated this around the x-axis, that means it would come right out of your computer screen, rotating towards you and down and around and the whole way back around. And what it would look like when you do that is something like this, a kind of funnily looking thing. But what I want you to kind of point out is notice we have a bunch of just little circles of different length each time, or should I say a different height, different radius each time. And they're all kind of flattened against each other, little disks, each with a radius of your function. So what we're looking at here is a million, or infinite, I should say, different circles. A circle's area is pi r squared, remember, all stacked up on top of each other. And the radius is just whatever the function value is. And that's how we get this formula that we use for finding volume. We have to take an integral of something, because we want to use an infinite number of these circles. And what we're going to do, there's your pi for the pi r squared. Here's the r squared, so the radius was the function. And all we need to talk about is how do we rotate it. If we rotate it around the x-axis, then we need to have something in terms of x. If we rotate it around the y-axis, then we need a function in terms of y. So it's just pi r squared, like we always do, but we need to do an integral because we want a bunch of little circles over and over again. So to show you how this works, we're going to do one with a horizontal axis and one with a vertical axis. In this first one, the thing is sine squared. We're bringing it around the x-axis, so this is how we want to rotate it. So it's going to kind of make kind of a football-looking shape, really. And all we need to do is this formula, pi times the radius is just the function, the square root of sine of x squared. So we can rewrite this. The square root of something squared is just the something. So just the integral of sine of x dx. Well, the integral of sine of x is going to be a negative cosine of x. And this is no longer an integral because I evaluated it. So I should be now plugging in into this 0 and pi. So if I plug in pi, cosine of pi is 1. So that gives me negative 1. When I plug in 0, cosine of 0 is also 1. So negative 1 again. Negative 1 minus negative 1. Alright, so it should have been cosine of pi is negative 1. We want the opposite of that, so that's positive 1. So we need to do positive 1 minus a negative 1. So that equals 2, and it's 2 times pi. So my answer for this volume is 2 pi cubic units. Alright, let's look at another example for how to do these. In this example here, they want it not rotated around the x-axis anymore. They want it to be rotated around the y-axis. And so to do that, here's the big thing. You always need to check, is my function in terms of the right variable? Well, it's in terms of x, but I want the y-axis, so I need to switch it to make it in terms of y. So I need to get x by itself. So to do that, I'm going to add x squared to both sides and subtract a y from both sides. And then I need to take the square root of both sides, and that'll give me x equals the square root of 1 minus y. There is my new function. Now I can go ahead and do a volume integral. Volume equals pi times the integral of my limits. Because I'm in terms of y, they need to come from where the y values intersect the axis. So here's the 0 where it intersects, and then 1 where it intersects. So that's my the area that's going to get rotated, and it's rotating around the y-axis. So from 0 to 1, the function is 1 minus y and a square root, all that squared, dy. Okay, let's simplify that. The square root of a square, those cancel each other out. So it's just pi times the integral 0 to 1 of 1 minus y dy. Let's now evaluate that integral. I still have the pi out in front. When I have with this pi out in front, it'll be, when I evaluate it, y minus 1/2 y squared, evaluating from 1 to 0. So that means when I plug in 1, I'm going to get 1 minus 1/2, which equals a half. If I plug in 0, I'm going to get 0 minus 0, which is 0. So 1/2 minus 0 is 1/2, and I need to multiply by pi. So my final answer is pi divided by 2 cubic units. So that's how you do generic volume. Just make sure you pay attention to what axis of revolution we're talking about.